Welcome, everyone. I am absolutely thrilled to have you here for today's explainer. We are going to unlock the roadmap to mastering what is arguably the ultimate superpower in modern business and tech, and that's data science. We're going to break down a comprehensive data analytics syllabus and decode exactly what it takes to turn raw, chaotic information into brilliant, actionable insight.
Okay, let's dive into this. What you're looking at isn't just some dry list of academic topics. It's really more like a video game map for today's journey. This official 5-unit sequence is designed to take you from the absolute basics, literally just understanding what data is, all the way up to building massive technological frameworks that can actually predict stock market trends. We're going to explore exactly how this curriculum builds a data hero, level by level.
So, here is our game plan. First, Intro to Data Analytics. Second, Advanced Data Analysis Techniques. Third, Mining Fast Data Streams. Fourth, Frequent Item Sets and Clustering. And finally, Frameworks and Visualizing Data.
Let's enter Level 1, Intro to Data Analytics, where we establish the absolute ground rules.
Our syllabus kicks off by asking a seemingly simple question: what actually is data? We look at its sources and its nature. Crucially, we learn how to classify it. You've got structured data, think of your neatly organized, clean spreadsheets. And then you've got unstructured data, which is all those messy emails and random social media posts. But you know, the most vital concept in this first unit is analytic scalability. How do we handle data when it just grows exponentially? And we also have to understand the critical difference between mere reporting, which just tells you what already happened, and true analysis, which digs into why it happened and what's going to happen next.
Still here in our first unit, the curriculum walks us chronologically through the data analytics lifecycle. Honestly, think of this as the scientific method for the digital age. You start with Step 1, Discovery, figuring out exactly what problem you're trying to solve. Then comes Step 2, Data Preparation. Listen, this is huge. You have to clean and organize your data. If you try to fast-track this, skip preparation and model planning, and just jump straight into Step 4, Model Building, well, your project is literally going to collapse. You have to clear those early hurdles before you can unlock model building, communicate your results, and finally put everything into operation.
Moving right along into Level 2, Advanced Data Analysis Techniques. This is the deep brain of the operation.
And this brilliantly illustrates the massive leap we take in Unit 2. We're moving from traditional models, things like your standard linear regression or time series analysis, straight into advanced learning techniques. Now, traditional models are fantastic for straightforward linear systems, but the syllabus pushes us way beyond that, into the complex territory of neural networks and Bayesian modeling. These advanced systems don't just crunch numbers, they focus on learning and generalization. They adapt to new information in ways that traditional models simply cannot do.
To actually achieve that advanced learning, the syllabus hands us a toolkit of seriously heavy-hitting mathematical methods. We're talking support vector methods for classifying really complex data, and stochastic search methods, which, by the way, essentially use controlled randomness to find solutions when traditional math is just too slow. And it gets incredibly fascinating when we look at extracting fuzzy models from data. I know fuzzy logic sounds like a total oxymoron, but it's actually a brilliant way for algorithms to handle the gray areas in complex data, finding patterns where things aren't just strictly black and white.
So up to this point, we've mostly been talking about analyzing static data. You know, information that's already been collected and is just sitting quietly in a database somewhere. But what happens when the data never stops? When it's just relentlessly flowing in every single second?
Welcome to Level 3, Mining Fast Data Streams. Things are about to speed up. Stream computing requires entirely new, high-stakes architectures. When your data is literally a rushing river, you can't possibly save all of it. So you have to learn these intense, on-the-fly techniques. You're sampling and filtering streams instantly. You're learning to mathematically count distinct elements and estimate moments just to grasp the overall shape of the data flow. You also track specific active elements in a set time frame. That's called counting oneness. But maybe the most fascinating concept here is the decaying window algorithm. It allows the system to prioritize the newest, most urgent data while letting the older stuff slowly fade out of the calculation. It is literally high-speed triage for data.
Now, if decaying windows and counting oneness sound a little bit dry, the syllabus grounds these concepts in some truly thrilling real-world stakes. These real-time analytics platforms are exactly what's powering instant sentiment analysis. Imagine tracking the public mood across the entire globe during a major live event. Or, even crazier, predicting high-frequency stock market movements. This is intense real-time action. It's math moving at the speed of the global economy.
All right, transitioning to Level 4, Frequent Item Sets and Clustering. This is the sorter phase.
A major star of this unit is the a priori algorithm. Let's define this clearly. At its core, this algorithm is used for mining frequent item sets and doing market-based modeling. Think of it as the ultimate retail detective. It uses what are called limited pass methods to efficiently handle enormous datasets right within a computer's main memory. Basically, it's the math that figures out that people who buy product A are highly likely to also buy product B.
Now, what's really interesting about this slide is how it prevents total cognitive overload. The syllabus categorizes this absolute alphabet soup of clustering techniques by your specific goal. Finding a needle in a haystack is easier when you know what kind of needle it is. So, if you just need standard grouping, you reach for hierarchical or k-means clustering. But if your data has massive amounts of variables, we call that high-dimensional data, you use specialized tools like Clique to find hidden clusters. And for the really out there advanced environments, you deploy clustering designed for non-Euclidean spaces, streams, and parallel processing. It's a perfectly organized toolkit.
And finally, we enter our expansive final level, Unit 5, Frameworks and Visualizing Data, the Factory and the Story.
Because let's be real, none of the brilliant math from the previous units matters at all if you don't have the architecture to actually run it. This is where the syllabus introduces the massive foundational infrastructures that make all this analytics physically possible. We're rapid-firing through the heavy hitters here, map-produced in Hadoop to split massive jobs across thousands of computers. We explore data warehousing with tools like Pig and Hive for querying. We look at NoSQL databases and sharding for storing that flexible, unstructured data. And of course, we map out essential storage ecosystems like HBase, MapR, and S3.
But having a massive infrastructure isn't quite enough, right? You need a way for humans to interface with it. So, the syllabus introduces R. It's pretty much the ultimate programming language and environment for statistical computing. We dive into R's graphical user interfaces, how to handle data import and export, and how to define attribute types. This is your workbench for exploratory data analysis. It's where you start translating that incredibly complex, unstructured math into descriptive statistics that actually make sense to us. So the crucial point is this: visualization translates math into human stories. The syllabus caps our whole journey off with visual data analysis techniques. It emphasizes that you have to visualize your data before analysis to really understand your raw material, and then you visualize it after to share your findings. Without interaction techniques and visual systems, you just have a giant, confusing pile of raw output. Visualization is the magic step that turns raw data into an actionable, world-changing story.
And there you have it. We've traveled from the simplest classifications of unstructured data all the way up to building massive Hadoop clusters and visualizing complex, fuzzy logic. It's a wild ride. But remember, at the end of the day, data is literally just noise until you build the framework and the skills to actually listen to it. This syllabus provides the exact blueprint to do just that. The only question left is, are you ready to build yours? Thanks for joining me on this explainer, and keep exploring.